Okay, so today we are going to start the lecture on 10th week. This week 10, verification and validation in ANSYS workbench, and we are looking at a loading of a stepped bar, right? So this is under the pages. Under the pages you have week 10, right? So I'll just show it to you. So now when we go to view all pages, right, you can see there are topics under week 1, week 2, week 3, like that. So I am going to focus on week 10, verification and validation, ANSYS stepped bar, right, week 10. So as you know, the learning outcomes, I don't have to go through with this. So the procedure is to define material, create a geometry in ANSYS workbench, or import a drawing from SolidWorks, meshing, defining boundary conditions, define loading, define required outputs, solution, and visualize, and also investigate the effects of certain variables that are changed, right? So now first we will launch ANSYS. Of course you have version 2019 or 220 and above, so I don't have to explain this part. So setting up the model. So we are going to load a CAD model from either from SolidWorks, or you can use any other CAD software. You can import it as a step or a IGS file, step file or a IGS file, right? So we can upload it to ANSYS geometry module, right? So this, of course, you know, model setup, solution, results, modules opens the mechanical application which can be used to set up the solve the simulation. So we define engineering data, right? Okay, so this part, of course, you know. This is also, now in here they are going to use the design modeler, but for us we can use the space claim modeling method, right? So this, of course, these steps are known. So now we will do a sample example. First we will solve this using the traditional FEA techniques. Later on we are going to use ANSYS to generate this step bar, and then load, apply a load on these two step bars, and then we are going to apply a force, and then we are going to analyze it using FEA, right? So we can use FEA ANSYS to confirm the answers obtained, including the reaction force and the supports, right? So first, now in this model, this sort of a cantilevered bar, right? A step bar which one end is fixed, the other end has a load, applied force P, which is equal to 10 newtons, right? There are two regions in the step bar, right? So there are two regions, region 1 and region 2. So we have to model this under region 1 and region 2. So step bar can be represented using two finite elements as shown, right? So this thing can be modeled using the nodes and elements. So this is sort of a line element, right? This is sort of a line element where you have three node points and two elements, two line elements, right? So K equals, now we know that the stiffness, we can use the stiffness matrix to these individual elements, right? So the first element and the second element, we can use k equals ae divided by l, 1 minus 1 minus 1 and 1. So this for the first spring coefficient, stiffness coefficient, you can use the area they have given as 20 square millimeters. So we apply that into the Young's modulus divided by the length. Right? The length is given as 100 for both cases, so we will apply those two and we can get the matrix. We get the matrix uh, as shown in this diagram, right? So as shown in this step, right? So now we will look at stress analysis of the step bar, right? So when you apply the boundary conditions, now the example, this is f equals k kx sort of equation set. So initially the force applied in this boundary region is 0 and here there is a reaction force which is R1. Let's say it is R1, right? So when you apply the boundary conditions, we can solve these two equations using after doing applying the boundary conditions, right? So when you solve this, you can get a deflection of 2.5 into 10 to the power of minus 7 and u3 is 7.5 into 10 to the power of minus 7. So you can calculate the strain as the difference between the deformation divided by the length, right? When you get it, you get something value something like this, 2.5 10 to the power of minus 6. And the strain at the strain of the second element, this is strain on the first element, right? This is strain on the second element, right? So you can calculate the strain in the second element. So now you can calculate the stress experienced by each element by using sigma equals E epsilon, that is the Hooke's law, right? You can use the Hooke's law to find the stress by using each element, right? So you find the stress at each element and also find the strains at each element. Now we will look at how we are going to model this in SolidWorks, and then we will calculate the values and we will find the stresses and the strains that are in this model, right? So we will go to ANSYS and see how we are going to solve this kind of a problem. How to model the stress analysis of a step bar using ANSYS, right? So I am using now earlier we used space claim modeling, but now I'm going to use the design modeler in order to model this problem, right? So now we will see how we are going to model using the design modeler. In this approach, I am going to model two line elements, and then with three nodes and two elements, I'm going to transfer that model into the mesh and the model generator, and then I will solve that using ANSYS. So first we will open static structural module. So first we will go to engineering data, edit. Now the material is structural steel, so we don't have to change anything. So we will be using the default structural steel, right? Then we will close this and go back to the project. Click on geometry, right click, select a new design modeler geometry. and now we have come to the geometry modeler. So we'll use this we'll use in this example, we will be using the xy plane, and we are going to model the line element somewhere in the x-axis, right? So we are using the origin, and then what my approach is, I'm going to fix this origin and then apply a force F onto this element. So I'm going to create two line bodies, and then I'm going to assign two different cross-sectional areas, and then I'm going to combine them using a form part method. So first we will create three nodes or 3 points, right? So in the xy plane I will click on this look at, right? Look at face or plane. So I click this, then it will orient the drawing sheet according to the screen. Then I will use create point, right? So point. Now if you look closely at the problem, the example one, the the lengths are basically 100 millimeters each, right? So first we will change the units. So we'll just exit from, we'll just we'll go to tools, concept, sorry, units and millimeters, and then you select this point, right click, then select edit selections. Now we will add the method we are going to use is from, not from coordinate file. So we click here and we select this, we click on this arrow, and then we're going to use manual input, right? So the first point is the fixed point, which is 0 0, that has a length of 100 millimeters. So the point should be in 0 0. So that is the first point, right? So we'll leave it as it is, right? And then we'll generate this point. So now we have created first point, which is in the origin. Now we'll create another point. We'll use definition, we will change the definition to manual input, and then the x coordinate for the second point is 100 millimeters. So y is 0 and z is also 0, so we'll generate this also. Then we will create another point, which is also a manual input, and then the distance from the origin is 200 millimeters. So we put 200 millimeters, right? And then we'll generate this point. So now in our model we see 3 points, right? This is the first point, which is the origin. First point is this point, and then first point is the origin point, second point is the midpoint, and then third point is the end point, right? Now we have to create line bodies between first point and the second point, and also another line body from second point to third point. So we'll create that, those two elements. So we go to create, or sorry, we go to concept, we'll create line bodies from points, right? Line bodies from points. So we'll select this, select this. Now they will ask you uh, what from where to where is the point segment. So you select this first point as this point, and then by pressing the control key you select the second point as this control edge. So now we have created one line segment. So when you click apply, and if you click generate, you can see we have created one body based on the first line, right? Now we'll create another body, lines from points. Now we'll click on this point, and then control and press this point, right? So we'll create another line body. Now we'll click on generate, and now we have created two bodies, but those two are combined, right? So for here, go to line 2 body, and then click here under the operation add, not add material, we'll click it as add frozen. This will enable two bodies, right? It will break up to two bodies. Okay, yeah, two bodies, right? So now we will create two cross sections which there now in this problem there are two cross sections in the region 1 and region 2, and the region 1 is 220 millimeter square millimeters and region 1 is 10 millimeter millimeter square. So first we'll create the two sections for line 1 and line 2. So we'll create, sorry, concept, go to cross sections, click on circular, right? Now the first cross section is a circular cross section which has an area of 20 millimeter square. So now if you use the 5r squared, first you have to find the radius. So 20 millimeters divided by 5, 20 millimeters divided by 5 will give you 6.366, and if you square root this you will get the first radius, that is 2.52313. So we'll use that value for the radius, 2.5231325, right? So it will give you a area of 20 millimeter squared, right? That is our first section. Then go to the again select create concept, cross section, circular. Now for the second circular cross section, the radius is 10 divided by shift 5, right? Then we take the square root, which will give you the radius of 1.7841, right? So 1.784124 will give you a area of 10 millimeter square. So we have created the first circular cross section which is 20 millimeter square, and the second cross section which is 10 millimeter square. Now we will apply these two cross sections for these two bodies. So under the bodies, for the first cross section line body, we will assign the circular one cross section for this body. So click on here, this circular one, and then for the second line body we will create another cross section which is circular 2. So now we have defined two line bodies. Next step is to convert these two bodies, sorry, form a new part using these two bodies. So we select, we press Ctrl key and select the first line body and the second line body, and then right click. You will have option called form a new part. So we click this and it will create one body which is combined, but it has two different properties. So we are going to use these properties to model our geometry. So we will save this project. So we'll go to our project folder and then we will create a new project, right? This is a new project. So now we'll go to the model. So click here, right click, and then select edit. Now we have created a model, right? Now we'll go to geometry. Under the geometry we have one body which has two line bodies, separate line bodies. So this line body, both of these line bodies should have the same material, which is structural steel. So if you look at the material section, you will see the assignment as structural steel for the first line body, and also second line body also has the same material, which is structural steel. Now we go to mesh, and then we'll put a size of how much it is. Let's put 2.5 millimeters, right? 2.5 millimeters, and then we'll generate the mesh. So right click on the mesh and generate mesh. So we have created a line body which has a good mesh resolution, right? So we have two line bodies. First one has an area of 20 millimeters squared, and second one has an area of 10 millimeters squared. Now we'll go to, now we have defined the material, and we have defined the supports. So we go to static structural. We need to fix this point at the base, then apply a force in the outside. Okay, so now first we will create a support. It's a fixed support, right? So now we have to select the geometry. I'm going to fix this endpoint as my geometry. So I'm going to use this point vertex or node selection method, right? Here there's a node point selection method. Click here. I'm going to fix this point as my first point, and then I will apply this point. So it is fixed, right? Now we'll go to static structure, create loads, and then select force. Now I'm going to apply a force in this direction. So we'll first select this point as my geometry. So click here and click apply, and we'll put a magnitude of the problem has a force of 10 newtons. So click this, and then the direction. Oh no, we'll this is a vector now, so we'll just select this as components. We'll select this as components. So the x component is 10 newtons. Y and z are 0 component. So now you can see, if you go back to the static structure model, this one point is fixed, point A is fixed, and point B you have applied a force of 10 newtons, right? So then we will add solutions to this problem. So we'll go to stress deformations, and select directional deformation. Now we'll apply a directional deformation in the x-axis, so we'll keep the orientation as x-axis, right? We'll go to solution, right click, insert, go to beam results, no, beam tool, select the beam tool, and under the beam tool there are a lot of options, right? So you can have the direct stress, and the minimum combined stress and maximum combined stress. We'll keep it as it is, and we'll solve this model. So we'll select this structural steel and right click, solve. We have solved this, and let's see the directional deformation. So as you can see, this end is fixed, and the free end has a deformation of 0.0007558, right? And then if you look at the direct stress, will have a direct stress of 1.008, maximum and minimum also the same. So what is important is the directional deformation, right? Right. So you can add uh, other definitions also, other solutions also. So go to solution, you can create, insert, go to beam results, you can click on this shear force, bending moment and shear force diagrams, right click here, insert, beam tool, beam results, shear force. I added shear force, I think. Yeah, I'll add shear force. Then if you solve this, you can see there is no shear force and no bending moment because we are applying a force which is perpendicular to this beam, right? So only the different directional difference. You can add other post processing details also, right? So basically, now this is how to model this beam using beam tool. So we'll save this, we'll close. So that will conclude the second the work for the week 10 lecture, which is step bar. So you can try out the other examples, right? You can try out, there are three more examples, right? There's one example with both ends are fixed and applying a force of 20 kilonewtons for example 2, and then also example 3. So in this example 2, the both ends are fixed. So for that, what I'm going to do here is I will just save this. So I will show you how to apply the forces, right? So in the second example, you will have two ends are fixed and applying a 200